Hi, I'm Michael McGurty, a business development manager at VMware. Today we're going to talk about new functionalities in the RAN. So we'll look at new functionalities being introduced into the radio access network and how they enable intelligence, scale, and performance improvements. But to begin, we will talk about how open interfaces are key to this. These standardized and open interfaces are being driven by the RAN alliances and associations. They're not merely an evolution of existing 4G networks. To achieve openness, flexibility, and intelligence in RAN, a new approach was needed. So we've seen with previous approaches for interoperability and multi-vendor RAN, such as CPRI or X2 interface, we've seen that the actual target was never quite achieved, maybe due to legacy considerations, compromises, or proprietary interfaces. The actual result was never quite the target. For 5G, a different approach was taken. We started off with the target of what we want, which is open, interoperable, multi-vendor networks, and work backwards to define the standards, the features, and the interfaces that are needed to provide this. So what we see here is a comparison of a traditional RAN and a multi-vendor RAN. So traditional RAN is comprised of a single vendor's radio unit, baseband unit, and management system, and typically these are connected via proprietary or closed interfaces. Below this, we have a multi-vendor RAN, where we can see the radio unit is provided by one vendor, the CUDU or RAN software provided by another vendor, and then the COTS hardware, the element management system by other vendors again. So here we have an open system with standardized and open interfaces, and CSPs can leverage that to choose the best hardware and software fit for their network. So in the traditional RAN or single RAN vendor case, we can see that a CSP is locked into a single vendor's roadmap and their speed of innovation. Whereas below this in the multi-vendor RAN, the CSP can leverage innovation at every point. So the radio vendor, they can choose different radio vendors for different use cases that best suits its needs, as well for RAN software vendors, COTS hardware to run these workloads. CSPs have a choice of which vendor to utilize for that, but can also swap out or introduce new vendors throughout the life cycle of the RAN because of these open and standardized interfaces. And so we've talked about today how we have open fronthaul and disaggregated hardware and software, which is providing choice and competition for CSPs. Next, we will see further definition of open interfaces for management and control, such as the E2, O1, and A1 interfaces. These will enable near real-time and non-real-time RICs, as well as service management and orchestration framework. With the RIC, we're already seeing innovative XApps to improve spectrum utilization and increase power saving, which will lower costs for energy and increase spectrum asset utilization for CSPs. With the SMO, we will see orchestration and automation of RAN components from multi-vendor FCAPS aggregation and intelligent SON through to network slicing and management. These will enable new paths to revenue and RAN monetization for CSPs. And we're already seeing the OpEx benefits that this automation can bring, with site deployment times being reduced from several hours per site to minutes. And this allows CSPs to scale quicker and decreases time to revenue for new services. So in summary, we have a new way of thinking about how radio access networks are architected, delivered, and operated. Today, this is a reality in the 4G and 5G Open RAN networks that are being deployed across the globe. Tomorrow, we will see the realization of end-to-end orchestration and automation with a wide ecosystem of XApp and RAP vendors providing innovative applications to lower costs and increase performance, and slicing and edge services that will enable CSPs to further monetize the RAN.